Alright, in this video I'm going to be going over integrating factor. So for integrating factor, all you need to know is mu of x, mu of x is equal to e to the integral of p of x. And what's p of x? So when you're given a differential equation, you always want to have it in like this form where dy dx is alone and everything else is like by itself, like that. So just make sure that dy dx is alone. So let's start with number one. So number one, we have x y prime minus y equals x squared. So we could rewrite it as x dy over dx minus y, which is equal to x squared. So as I mentioned before, we want to isolate dy dx, like just have it by itself, no coefficients. So we're going to divide by x, and then we're left over with dy dx minus y over x, which is equal to x, because we divided everything by x. So now we want to identify p of x. So p of x is going to be the coefficient of y. So in this case, p of x is minus 1 over x. So that's p of x. It's just going to be the coefficient of y. So that's the general idea for identifying p of x. Because you also got to use integrating factor, you have to make sure that the equation is first order and linear. So this equation is first order and linear, so we're able to use integrating factor. So now to move along with the problem, once we identified p of x, we got to find mu of x. So mu of x, as I mentioned here, is going to be e to the integral of p of x. But we established p of x is just minus 1 over x. So now mu of x is going to be e. When we take the integral, it's going to be ln x. There's a minus sign, so minus ln x. And ln and e undo each other. So we're just left over with 1 over x. And that's because this minus sign could serve as an exponent. So when they undo each other, it's just x to the negative 1. So this is your mu of x. So once you have mu of x, to proceed with the problem, what you need to do is multiply by y on one side and multiply by the other side of this equation. So let me write that out for you. So y times mu of x, it's always going to be y. And then you set it equal to x, this part of this equation. Always make sure you're using the equation that where you isolated the dy dx, where it's just by itself. So this is also known as q of x. But yeah, so it's going to be x times 1 over x, which is mu of x. And you're going to be integrating. So to proceed with the problem, you have y over x is equal to the integral of just 1, because x over x is 1. And that's just x plus c. And then you're left with y is equal to x squared plus cx, and that's your general solution. So generally what you need to do is find mu of x, then do y mu of x is equal to the integral of q of x times mu of x. As I said before, q of x is just this side of the equation. Alright, so this is number 2. You could pause the video here to give it a try yourself. So to proceed, we could rewrite this as t dy dx, but as I mentioned before, we're going to divide by t, so dy dx is by itself. So we have t plus 1 over t, y equals to 2e to the minus t. So now we're going to identify mu of x. So mu of x is equal to e to the integral of t plus 1 over t, because that's p of x, because p of x is the coefficient of y. So it's this. So to evaluate this integral, we can say t over t plus 1 over t. So it's equal to e to the integral of 1 plus 1 over t, because it's the same denominator. And you could just separate it. And we know what this is. This is going to be e t plus ln t. And then we're going to separate it. So equal to e to the t times e to the ln t. And this is just t e to the t, because the e's and the ln cancel. So now that we have mu of t, as I mentioned before, we're going to say y mu of x, so y t e to the t is going to be equal to the integral. So we're going to use this equation, and we're going to use the other side, so q of x right here. So 2e to the minus t times mu of t, which is t e to the t. So now y t e to the t is equal to the integral of the e and the t's cancel out because negative 1 plus 1 is just 0. So you're just left with 2t dt. And then this becomes yt e to the t is equal to 2t squared over 2, which is just t squared, plus c. And now this just becomes y is equal to t squared over t e to the t plus c over t e to the t. However, this is an initial value problem, so we need to make sure to plug in the initial value and solve for c. So we have y of 1 is equal to a, so for y we're going to plug in a, and for t we're going to plug in 1, so 1 over e plus c over e, and this becomes c over e is equal to a minus 1 over e, and you multiply by e, so c is equal to ea minus 1. So we could rewrite our solution as y is equal to t squared over t e t. Well, actually the t squared and the t cancel out, so it's just y equals t over e to the t plus ea minus 1 over t e to the t. Alright, so this is number 3. Cosine x y prime plus sine x y is equal to cosine x. You could pause the video and give it a shot here. Well, I'm going to proceed. So we're going to have dy dx, because that's y prime. We're going to divide by cosine x, so sine x over cosine x. And then y is equal, so cosine x divided by cosine x is just 1. So now we're going to find mu of x, which is going to be e to the integral of sine x over cosine x, because that's our p of x, since it's the coefficient of y. And now here will just be a quick u sub. So u is equal to cosine x, du is equal to sine x, or negative sine x dx. So we have e to the integral of minus du over u, and this is just e to the minus ln x, well, e to the ln minus ln u, which is equal to e to the minus ln cosine x, because that we replaced u with. And now we're going to cancel out the e and the ln, so we're just left with cosine x to negative 1, and that's our mu of x. So now we do y mu of x on one side, so y cosine x to negative 1, but actually let's just do y over cosine x, so y over cosine x, and set it equal to the integral. We're going to use this equation, and q of x is going to be the one on the other side, so this is q of x. So it's q of x times mu of x, and that's just cosine x to the negative 1, so that would be just secant x. And the integral of secant x is ln secant x plus tan x, and then plus c, y over cosine. So now we need to isolate y, so y is equal to cosine x ln secant x plus tan x, and then plus cosine x c cosine x. So let me write that over here. C and cosine x. And this would be your general solution. So this was the general solution, but if we were given an IVP, so let's say it was this, an initial value, so y of pi over 4 is equal to 1 over root 2, then all we would need to do is solve for c. So plug in 1 over 2 for y, and then plug in pi over 4 for cosine, so that would be root 2 over 2, and then ln. So this would be 2 over root 2 plus 1, and then plus c root 2 over 2. And now we just simplify. So c would be equal to 1 over root 2 minus root 2 over 2 ln 2 over root 2 plus 1. And we'd be dividing, well, not dividing, we'd multiply by the reciprocal of the coefficient of c here. So it'd be all this times 2 over root 2. And then we'd get c is equal to 1 minus ln of 2 over root 2 plus 1. So the final solution would be y is equal to cosine x ln secant x plus tan x plus parentheses 1 minus ln. We could simplify the 2 over root 2 to just root 2, because if you multiply top and bottom of root 2, so it'll be root 2 plus 1, and cosine x. This would be your final answer for the IVP.